Okay, this is Sherry. I am back for another college algebra video. The focus of this video is going to be all of the log rules. So I included in another video how important it is that you learn these log rules. So here they are. I know it looks like a lot. I've tried to color code them to break up the page a little bit, make it a little bit easier for your eyes to digest. I'm actually going to do a total of 3 videos to split out the log rules. Numbers 1 through 6 here I'm going to cover in this first video, and then I will do a separate video on number 7, which talks about change of base, and then another separate video on number 8, which talks about expanding or combining logs. These numbers are just a notation that I've given to try to help you keep track of them. The order of the log rules does not matter. There's really no significance to these numbers other than it's just the order that I'm teaching, intending to introduce them in. Okay, so I'm going to give a brief overview of the rules, and then I'm going to show you how to use them with some specific examples. All right. I was given a little bit of feedback that my previous video was a little boring, so I apologize. Not too sure how to make it a little bit more lively. The good news is if you happen to fall asleep, you can just replay the video, right? So as many times as you need. Okay, so let's get going. This first log rule is really important. It is the log rule that talks about how you can switch back and forth between log form and exponential form. I talked about in a previous video that log functions and exponential functions, those two parent functions, are actually inverses of each other, which forms an entire foundation for why we can do this. But taking an equation in log form and learning how to write it in its exponential form instead, or vice versa, is critical. It's a skill that we're going to use later when we actually start solving equations that are of this type. So how you do this, if you have an equation in log form, again, this A represents the argument. It is like stuck inside of that log, and this represents the base. If you want to be able to isolate the argument and get it out of that log, we can switch it into exponential form. And so the argument ends up written by itself. So we say that A equals the base goes here, and then whatever that expression one that was over here isolated by itself, that actually now becomes the power. So being able to go from log to exponential and back and forth is a key skill. These next couple of rules, these next 3, I like to call them just rules that you need to just recognize. They just are. Kind of like 1 + 1 is 2. These rules, you just need to recognize them, because when you see them come into play, you actually can use them to simplify expressions. And so what the first one is, says that the log of 1 is 0. It does not matter what the base is. This base could be 2, 3, 10e, doesn't matter. The log of 1 is always 0. This next one talks about if you have the log, if the argument and the base, if they match, if they're both 2's, if they're both 10's, if they're both e's, that will always simplify to be 1. It's that straightforward. So you learn to recognize that pattern, because if you see this, you can just simplify it and call it 1. Pretty neat. This next log rule, number 4, this is not one that you actually see that often. So again, it's just something that you learn to recognize. And what it is if you have a base, which again is just some number, and that base happens to be raised to a power, and that power happens to be a log, if the base of that log matches the base of the exponent, then the answer is it just simply simplifies to what that argument was. So again, you don't see this log rule a lot, but it's important that you recognize it, because it's a very simple problem when you come across it. The fifth log rule is very, very powerful. It's called the power property. It's actually one of my favorite log rules. You use this a lot when you're solving problems. And if you'll notice, you have the log. The argument is something raised to a power. This is not the entire log raised to a power. It's the argument raised to a power. And what you actually get to do is, if you notice that, you can take this power and you can actually just pop it down in front of the log. It becomes a multiplier instead. And that's what I have written here. So again, this is called the power property, and it's very powerful. If you combine rule number 3 and rule number 5, you actually end up with this rule right here. If you can see, if you can imagine this, I have an argument raised to a power. I could see myself taking that power and moving it down in the front. So now I have n times this log, but this, if you remember from rule number 3 above, that is just 1. So you really end up with n times 1, or in other words, just n. So again, this is a pretty powerful log rule. It allows you to simplify things using pencil and paper instead of having to use a calculator. Okay, these last 2 log rules, I'll introduce just briefly. This one is called change of base, because I'm going to do a separate video on this. But if whatever your base is, you could choose to rewrite this using change of base as a log divided by a log. The key is when you do the log divided by the log, this base has to match. They could both be 2. They could both be 3. They could both be 10. They could both be the natural log. The key is that the argument is put into the log up top, and the base is put in as the argument down in the bottom. And this becomes really powerful because it allows us to use our calculator to do some computations that we potentially otherwise couldn't do. This bottom rule is called expanding or combining logs. Again, this is very powerful. We use this a lot when we're solving equations. And basically, it allows you to take a single log and break it up into the addition or subtraction of multiple logs. And just like you could go from a single log into an expanded log, we could do the reverse as well. We could take the sum or addition of multiple logs, as long as they all have the same base, and we could consolidate those back into a single log. And again, this is a skill that we're going to use in solving equations. So I'm going to go through some examples now from log rules kind of 1 to 6, and then I'm going to do 7 and 8 in separate videos. Okay, so here we go. Before I get into the log rules, I actually wanted to mention something about the natural log and the common log. And so I spoke in an earlier video about 2 bases that show up a lot, in the real world. And that happens to be a base of 10, which we call the common log, or a base of e, which is the natural number. The base of e we call the natural log. And remember, e is just that number 2.71828. I could keep on going. It's an irrational number that has an infinite number of decimals. So again, these 2 bases, they show up a lot in the real world. And so mathematicians, because we are inherently always looking for the simplest way to do things, I know that may come as a surprise to many of you, but it is true. These 2 logs show up so much in the real world that we came up with a shorthand notation to denote them. And so if you ever see just the log of an argument and there's no base, notice there's nothing written there. It's implied that it's 10. So when you see this notation, it is the common log. And even though we don't write the 10, we know that it's there, okay? The second one, the natural log, again, it shows up a lot. You're going to see this guy in word problems later. We couldn't use the trick to just not write the base. We'd already used that trick for the common log. So what we do for this one instead of writing log, we actually write ln. So if you see ln, that means it is the natural log, or in other words, the log base e. So we'll see it like this. So again, you'll notice we don't put the base, it's implied that it's an E because we've used the ln instead of the log. And so these aren't really log rules, it's just more log notation that mathematicians have adopted. And in fact, these two logs show up so much that when it comes time to doing problems later in the calculator, they actually have their own buttons on the calculator. So the LOG button here, that's log base 10, and the LN button, that is the natural log. Again, they show up so often, we have given them special notation, and they have their very own buttons on the calculator. So I just want to call that out as we get ready to progress through the log rules. Okay, that first rule we talked about was going back and forth between log form and exponential form. And if you remember, the goal of that is to isolate that argument. So we take that argument and we write it by itself. So the argument equals the base goes here, and this term that was by itself before, it goes up to the power position, and you should be able to go backwards and forwards. So what we're going to do is we're going to practice a couple of these and see. I have 3 examples of something that's in log form. We're going to practice writing them in exponential form, and then likewise we have 3 that are in exponential form. We're going to practice writing those back in log form to see if you can get good at that. Some students find that maybe going from one to the other is easier, and when they get ready to go backwards they have to think about it more. That's completely okay. Me personally, I am pretty quick at going from log into exponential, but sometimes when I do exponential backwards, I have to think about that for a second. Okay, so if we follow the process to switch this log into exponential form, here's my argument right here. It's that 16. So I'm going to write this as 16, try to get my hand out of the way, 16 equals the base, the 4 comes next, and then this becomes my power. So 16 equals 4 squared. And that's a true statement, so that should make sense to you as well. Okay, this next one, notice there is no base right here. But we talked about before, if you don't see a base there and you see LOG, it is a 10, and sometimes writing it in physically allows you to make the transition. Sometimes when our eye doesn't see it, we struggle with the conversion. So just do yourself a favor, go ahead and write it in, and then you will be less likely to make a mistake. So again, if I take that argument, which happens to be 1,000, I'm going to write 1,000 equals, and then that base comes next, and this becomes that power. And that's a true statement as well. Okay, so finally this last one, again, the base is noticeably absent, but because this is a natural log, I know that it's an E, so I'm going to go ahead and write it in. And then if I do my conversion, the argument right here, that is E cubed, and that equals, and then I have my base, and then this becomes my power. Again, a true statement. So that's pretty straightforward going from log into exponential. So now let's see if we can go backwards, okay? So notice that this I have a number to a power equals a number. If looking at it this way messes with your brain a little bit, you could rewrite it like this. So whichever way is easier for you to think about it, write it the way that best suits you. So if it's provided for you this way, but you'd rather look at it like this, just flip them, okay? Do whatever's easiest for you to make sure you can get this right. So if you remember, when you look at the exponential form, this thing that's by itself, that is what used to be in the argument of the log. So to get ready for all 3 of these, I'm just going to go ahead and write the word log, because I know I'm going to be turning these into logs, okay? So that's the goal. The question is what goes where. The item that was by itself, that gets embedded inside the log. This is the base of the exponent, so it was the base of the log. So there it goes. And the power is what used to be by itself if we'd written it as a log. Okay, so the same thing applies for these next 2. So the 4 is what is by itself. we're going to embed that in as the argument of the log. This is my base, and this becomes the number that's off by itself, okay? And one more, this is what's going to be inside that log, okay? This was my base, so I'm going to fill it in as the base, and this power is what was by itself. Now some of you may notice that I now have the log of v, so yes, we could just write this as ln, I'll do that off to the side here, as ln of 1/2 equals negative 4x. So this would be the preferred way to write it since it is the natural log. Okay, so that is a quick overview of going back and forth between log and exponential form and vice versa. Very, very important skill. Okay. The next 3 log rules were ones that I talked about that you just need to recognize. You'll be working on simplification problems where it may say simplify this or write it a different way, and you just need to recognize it and execute this step. So you should get really good at this. So remember, this log rule is the log of 1, no matter what the base is, it's always 0. So here I have the log of 1. So it's 0. Right here, the log of 1, that is 0. This one, don't let it confuse you if there's a multiplier out front. This is still 0 because really you have 3 times this piece right here. I have the log of 1, that is 0, and anything times 0 is still 0. So pretty straightforward log rule. This one is again very powerful as well. Remember, it's the log rule that if your base here and your argument, if they match perfectly, that simplifies to 1. So again, pretty straightforward when you recognize it. So these match, so this equals 1. This one here, again, you just have a multiplier, okay? So this negative 2 multiplies, and this piece right here, that is 1 because the argument and the base match. So you really have negative 2 times 1, which ends up being negative 2. Okay, this one, again, when you have the common log and the natural log, sometimes your eye misses it because that base is not written. So if it's not there, I encourage you, consider writing it in. Put in the 10, put in the E, and then maybe you'll see that log rule that's staring at you where the base and the argument match. So again, these are both just 1s as well. Okay, this last one on these rules that I recommend you just need to recognize. This is that rule that I talked about. It doesn't show up a whole lot, but when it does, you just want to see it and execute it nice and clean. So I have a 4 raised to a power. That power happens to be a log. The base of the log matches the base of the exponent, so that is nice and simple. That answer is just 5. Again, whatever's sitting there in the argument of that log, that becomes your answer. So this one, the A's match. I've got an M sitting there, so pretty clean. Okay, so again, these 3 log rules, there's not a lot of manipulation there. You just need to recognize them and use them to simplify when they show up, all right? Okay, this is one of my favorite log rules. This is called the power property of logs, and it's pretty slick. When you have a log, when you have the argument being raised to a power, and again, this is not this entire log being raised to the power, it's the argument raised to a power. And what you can do, you can actually take that power, like I showed you before, and you can move it down in front as a multiplier for that log. Very, very powerful log rule, and we're going to use this guy a lot when we start manipulating equations. So again, we're just going to do a couple of practices. So here I have x squared. I could take that 2 and I could bring it down in front as a multiplier. So instead I'm going to write this as 2 times the log of x, and my base is still a 3. Okay, pretty simple. This one, if you notice, these don't match, but could you rewrite 8 as 2 to a power? Because if you could take this argument and write it as 2 to a power, then you would have the combination of the rule I talked before, which is down here. So sometimes they may ask you to simplify a log problem, and you look at it and you say, I can't really do anything. But a good way to train your brain is to always ask yourself, could I take this argument and rewrite it as something to a power where that thing is this base? So if you think about it, 8 is 2 cubed. So we're going to go ahead and rewrite 8 as 2 cubed. And now we have that rule going on where this power can drop down in front. So I'm going to rewrite that as 3 times the log of 2, base 2. This was that log rule that equals 1. So this is actually just 3 times 1, which is 3. And some of you may have noticed that right back here, because again, you would have seen that this is this log rule right here. You don't need to carry out all these steps individually. If you see it right here, go ahead and just say that that answer is 3, okay? And when you get good at these, that will become pretty efficient for you. This one, if you look at this and I were to say simplify this, some students might sit there and say, not quite sure how to do that, Guy. Again, one of my pieces of advice is if your base is not written, please consider writing it in. It might make something stand out to you that your brain didn't see before. And now if you're thinking, wow, these almost match, could I do something to manipulate this to get the argument and the base to match? Well, if you remember from earlier algebra classes, you can take a radical and write it as an exponent. So a blast from the past, the square root of 10 is actually the same thing as 10 to the 1/2. So if I rewrite this radical as an exponent, it's called a fractional exponent. If I do that, and if I remember my base is 10, you see now that again, this log rule is staring at you. These match, and so this simplifies to actually just 1/2, okay? So this power property of logs, in conjunction with this one, very powerful. What it does is it allows you to simplify a lot of problems by hand where you don't have to get a calculator out to determine what those expressions are equal to. Now there are a lot of log problems that you do need to use a calculator on because these rules, they're not there. They're not a piece of the problem, and that's what we're going to do in the next video is talk about change of base, because typically you would want to do that if you have a problem and you cannot see how to manipulate it, you're using log rules to get that simple answer. You could do these in a calculator as well and it would give you the right answer, but instructors want you to use log rules. They want you to practice using these to get that answer instead of using the calculator. So that wraps up the log rules. What I wanted to point out again was here they are. We've covered these 6, and I will cover these additional 2 in separate videos. I do want to take a minute to show you, we do have a summary page that's available on the MCC website of all the log rules, and I'm going to show you how to get to that so you could pull it up on your own if you would like to. So I'm going to switch off of this screen, and I'm going to pull up the MCC website. So here is the MCC website. Hopefully you recognize it. This is just the mcckc.edu. Again, if you come to current students, we have lots of great stuff here. So current students, you're going to go down to the bottom of this drop down and click on the tutoring section there. And then what that does is it brings up information about each campus. If I scroll down and off to the left here, we see each campus listed. Well, you're going to click on the Blue River tab and go to the Math Lab. And if you do that, we have some awesome handouts that are available. Whoops, I did that a little faster than I wanted to. So you can see they're separated kind of by topic. We've got algebra handouts, basic math handouts, calculus, trig, etc., equations and inequalities. This is a section I want to get to. Exponents and logarithms. We have a variety of handouts here that you might find useful as you're studying this chapter. In particular, I'm going to click on the properties of log functions, the second one from the bottom. And if I pull that up, here is a handout that basically lists all these same log rules I just went through. The numbers may not be the same, but they're all the same log rules. There's a couple of them, number 2 and number 3, that I combined into the same rule, which is the combining and expanding logs that we'll cover in another video. But anyway, this is a very useful sheet that you may want to reference if you're trying to learn these log rules. So that is my best advice to you, is learn the log rules. You will master this material much more quickly the sooner you understand and can use these log rules. I hope that helps clear some of the fog with this topic, and I will talk to you in the next video.